Project code ITPW17 project title Simplified Hybrid AC to DC Microgrid with a novel interlinking converter. Actually, in a hybrid AC to DC microgrid have capable of connecting AC and DC microgrid in a single converter. In a single conversion, AC and DC conversions take place. Existing concept in conventional AC to DC converter, AC to AC converter. In case the hybrid AC to DC operation and DC to DC operation, these are all in a single converter. In case DC is given as the input, which is converted into AC, and this DC is again converted into DC. This combination made unique in a proposed hybrid microgrid. This AC is connected in a grid and DC is connected in a grid. The both grid is connected. So in case in a conventional, in a AC to DC, DC to DC, again DC to AC, combine three all in this existing concept and having 12 MOSFET switch. In AC to DC operation having 6 switches and other DC to AC having 6 switches to combine to form the 12 switches. And this combination did not unidirectional. It did not bidirectional. It is only unidirectional. It is one side only. It will transfer the energy. And the step-up operation is also not possible in existing concept. In case in between other DC to DC converter, step-down converter or step-up converter is required for the step-up and step-down option. The existing drawback, and in existing case there is no galvanic isolation because directly AC to DC and DC to AC will happen, but there is no galvanic isolation. There is no isolated like coupled inductor which is placed in between these two conversion because it having the galvanic isolation between the input and output, and which is not suited for the low power application. The existing concept. Proposed concept hybrid AC to DC microgrid. So the AC is given and connected to the DC grid in a unidirectional, and again this AC is connected with the other DC load with the coupled inductor which give the galvanic isolation. This is bidirectional. In case they both AC and the DC microgrid have transferred the energy in between. That in a proposed concept having the advantage of galvanic isolation, and it is suited for the high and low power application, and switching count also less when compared to the existing concept. Black diagram. AC is connected to the DC converter. In between controlled AC to DC converter, and again isolated converter and controlled. Here it is uncontrolled converter. With controlled means using gate like MOSFET, IGBT type of switches is used in a control switch. Uncontrolled switch is only the diode is used in this converter and connected to the DC load. Mainly it is used for DC microgrid application and renewable energy application and power compensation. This concept is implemented in MATLAB 2015 version. Here the microprocessor lab is used because the microprocessor lab having capable of giving the program to pick microcontroller in a prototype for generating the pulses. The existing concept, the minimum hardware requirement is power MOSFET transformer which is used to excite the PIC microcontroller, and other active and passive components are used. Thank you.